Alright, what we're going to do is we're going to solve a few problems using the reciprocal identities and using the quotient identities. Right. The first problem that we're going to look at is, let's say that I give you the cosecant of theta is 7/4. And I ask you to find sine theta. The first thing I need you to realize is that the cosecant and the sine are reciprocals of one another. Right there. So that means that all you have to do is flip. The 7/4 becomes 4/7. And that would be the answer. Or let's say that I give you that the secant x is equal to 5/3. And I ask you to find the cosine x. Well, you have to understand that the secant and the cosine are reciprocals of one another, so all you have to do is flip. So this becomes 3/5. And that would be the answer. Now, these are two problems that all you have to use is the reciprocal functions. There might be problems that you have to use the quotient identities, where tangent is equal to sine theta over cosine theta, and cotangent is equal to cosine over sine theta. And this would be an example of when you use those. So let's say that I give you that the cotangent of x is equal to 2/5 square root of 5, and sine x is equal to the square root of 5/3. Okay. I want you to find cosine x. So the first thing you need to realize is that the cotangent gives you the tangent and the sine gives you the cosecant, none of which help you find the cosine. So you need to have a relationship between them. So what you do is you take the quotient identity that says that the cotangent of x is equal to cosine x over sine x. You're looking for the cosine. You have the sine and you have the cotangent. Right? So by having those two, you're able to solve for the cosine. So what we're going to do is we're going to rearrange this, and we're going to get rid of the sine x. Because sine x is in the denominator, what we're going to do is we're going to multiply both sides by sine x. And what happens is this sine x cancels that sine x. And you're left with cosine x is equal to sine x times cotangent x. And all we have to do now is plug in. Sine x is equal to the square root of 5/3. And cotangent x is equal to 2/5 square root of 5. And what I realize when I do this is that the square roots of 5's cancel. And I'm left with 2/3 times 5, which is just 2/15. And that is the answer.